All right, my goal here is to figure out what Kn is. So I have this number line over here, and my goal is to figure out what the distance between K and N here. So remember, if I'm looking for the distance between 2 points on a number line, I'm going to use this formula. It's basically the absolute value of x2 minus x1, or you can say the absolute value of x sub 1 minus x sub 2. So let's call this, I don't know, x sub 2, and I'm going to call that x sub 1. So I take the absolute value of -4 minus, that's a positive 3 over here. So then that's just going to be the absolute value of -7, so 7. Okay. Remember, the absolute value is how far a number is away from 0. So by looking at this number, how far is -7 away from 0? It would be 7. Okay. Now what I want to go ahead and do is find the value of Jp. So J is here and P is here. I gotta go find Jp. That means I gotta find the distance. So again, using that formula over here, I'm gonna call this x sub 2, x sub 1. So absolute value of negative. So Jp is the absolute value of -7 minus 5, which is -12. So that's just gonna be 12. And to figure out the midpoint, recall that the midpoint formula is basically taking those 2 points, adding them, and then dividing by 2. So to find the midpoint of segment JP, it's basically -7 plus 5 all over 2, which is equal to -2 over 2, simply -1. So -1 is between those 2 points. And make sure on the test that you are showing your work, so that way that you can receive credit on the exam. Number 16, this is a different scenario. We have this image over here. Find the value of x and y if the segment UV bisects the segment TV. Now I know that when we say bisect, we're associating that with angles and stuff, but we're dealing with segments here, and a segment can actually bisect another segment, and what that happens is going to split that segment into 2 congruent parts, right? So here, what really, if we take a look at this image, we have this segment here, which bisects this segment here, and because they intersect at this particular point, bisecting, which means splitting that segment into 2 congruent parts, and bisecting in this scenario, it creates that midpoint, hence that this and this are definitely congruent. So tick mark here, okay? So that means that I am definitely, if I want to set my equation, these are definitely going to be equal to each other. But the problem here is, if I equal these to each other, well, I have an x on the left side and y on the right side, and I can't do the algebra. So I really need to figure out, okay, I need to plug into either x or y so I can solve for one of the variables here, right? And if we look back at 16, find the value of x and y if segment UV bisects segment TV and UV is 40. Well, look at this. I have one expression with y and the other expression with y. Part plus part is equal to a whole. And by the way, I just want to make sure we're all clear. Just because this bisects this does not mean that this is congruent to this. We cannot assume that just because this is the bisector, it means that this segment and this segment are congruent. We cannot assume that, but we can assume that this is congruent to that because of this. So remember, part plus part is equal to whole. So I have UZ plus ZV equals, well, what is it, 40? Or I'm sorry, that should be UV. Then I'm going to replace. So I have 3y minus 1 plus 2y plus 6 equals 40. So that's going to be 5y plus 5 equals 40. So 5y is equal to 35. Therefore, y is equal to 7. Because we found that y is equal to 7, then this right here, I can replace that y with 7. So that's going to be 3 times 7 plus 1. So 3 times 7 is 21 plus 1 is 22. So I don't really need this anymore because I know that this segment here is 22. And recall that, again, this segment and this segment are congruent due to the fact that UV is the bisector of TW. So I can set up my equation as follows. So I can do 3x minus, or I can say this, TZ is equal to ZW, and TZ is 3x minus 2. And I set that equal to 22. I don't really need that expression. What was it before? It was like 3y plus 1. I don't need that anymore. I can just replace that with 22. Add both sides by 2. So 3x is equal to 24. So x is equal to 8. And am I done? Yes, because I just only need to find x and y. That is your strategy, or that is your game plan to figure out number 16. Number 17, for the diagram below, classify each angle as right, acute, or obtuse. Okay? So, angle AFB. So I have AFB. That kind of looks like a small angle, so I'm going to assume that's acute. And then angle Chick-fil-A, CFA. So CFA. Yes, because this is 90 degrees, and this right here, that's also 90 degrees, so that's a right angle, right? Because if you have a square here, you can assume that this part right here is a square, which will make a line. And then the next one is angle, BFE? BFE, that's pretty fat, so I'm going to call that obtuse. I'm going to call that obtuse. Oh, name the sides of angle BFE. So looking at this again, remember, these sides are either the rays or maybe the segments. In this case, we look closely, we see these arrows, they are definitely rays. So remember, when we're naming rays, we start at the endpoint and then where the line goes towards, which is going to A. So we start at F, it's going to A, draw a little ray symbol above, and then we got to look at the other one. Wait, what am I doing? Oh no, this is absolutely wrong. I apologize. I was looking at this one right here instead of this one. Alright, again, it's F to B. So we start at F and then it's going to B. Draw a ray symbol. There you go. You got an arrow above FB. And then looking at this, you start at F and it's going towards E. Draw that ray symbol above, and there you have it. Find the value of each variable. Okay. Here, this is where you need to know your terms and definitions. If you don't know your terms and definitions, you don't know your vocabulary, you don't know how to do this problem. So, with these lines here, they intersect, that's awesome, and they form a beautiful X, right? You can see that. So that means we can play the vertical angles game. So if I look at this, I'm like, okay, this and this, they gotta be congruent, right? They gotta be congruent. They are equal to each other. So let's write that down. We can say that 2y plus 6 is equal to 8y minus 102. And then I can solve for x. So I got 108 equals 6y. Divide both sides by 6, so you get 18 is equal to y. Perfect, okay? So then, I can do multiple things. I can replace this y with 18, or I can replace this y with 18. Well, I don't really want to replace this y with 18 because I just got big numbers, and 8 times 18 is something I can't do in my head. So I'm going to use this one. I'm going to replace this y, and the reason why I'm going to replace either of these y's, but I'm choosing this one, is because I need to figure out what the value of x here is. So what happens here is that they share a common side here, and because they have a straight line, they share a common side, I can say that this is a linear pair. So that means I can add these angles up to 180 degrees. But again, I got to replace that y with 18, so it's going to be what? 2 times 18, 2 times 18 plus 6. 18 times 2 is 36 plus 6. Man, that's going to be 42. So then I have what? 42 plus 3x is equal to 180 degrees. Again, it's a linear pair. It's supplementary. They add up to 180. So 42 plus 3x equals 180 minus the 42 on both sides. So 3x is equal to 138. I believe, yes, that's going to be 138. And then if I divide both sides by 3, you get x is equal to 46, and then you got it. You found what x is equal to, you found what y is equal to. You got it, okay? Alrighty, see you in the next one.